All right, everybody, we just got our okay to start our final planetarium show of the day. Someone put away our space trivia questions because now we're heading into the unknown. And welcome everybody to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter. And just to let you know, I'm not just a voice coming out of the walls. I'm actually a person standing right behind you at the top of the planetarium. Hey, good afternoon, everybody. Good to see you. Don't hurt your necks, though. Look forward into the dome before you. Everything that you see in purple is going to be one really big screen, thanks to help of 6 different projectors hidden throughout our planetarium dome. If you're looking for our projector system, it's hidden just below the purple glow. And folks, I'm happy to have you here because you're here for my favorite planetarium show. This one's called Tour of the Universe. This show is completely live. What that means is that you're going to hear my voice for the next 30 minutes, and I want to free fly us through space, and we're going to start off pretty close to the Earth, and we're going to be zooming all the way out to the edge of the observable universe. Hopefully, by the end of this show, you won't have an existential crisis of where we are in space. But just to let you know, we're pretty small in the grand scheme of things, so just a forewarning. And before we get started, I got to go over some quick house rules just so that we're all on the same page and have a good time. First off, there's no food or drinks allowed in, so if you brought any snacks, make sure those are put away till the end of the show. Also, if you happen to have any cell phones, smartwatches, anything that makes loud noise or bright white light, now's a good time to put those devices away. These can be very distracting. And if you need to leave early during our show, the exits are always at the top of the planetarium, so always make your way up the stairs to exit. If the staircase is too steep for you to climb, don't worry, just remain seated. Once the show's over, we'll have a staff member escort you to a lower exit when the show is over. And lastly, folks, this show is very immersive thanks to our 75-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, there's a really quick and easy trick to ground yourself. All you have to do is close your eyes, take in a few big deep breaths, then your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling all the way to the edge of the observable universe. At least not more than the usual. But with that being said, it looks like we're ready to go. So I invite y'all to sit back, relax, and let's begin our tour of the universe. And like I said, folks, we're going to be starting off pretty close to our planet Earth. You can see all the city lights just down below, but we're going to be starting off at this really amazing human feat. This is the International Space Station, or the ISS for short. And a lot of people tend to ask me, hey, Christian, what is this thing? I always hear about it in the news and online, but I don't really know what it is. Well, folks, the International Space Station is a research facility that's orbiting around our planet Earth. And they conduct many different types of experiments up here, a little bit further away from our planet with less gravity. Some of the experiments they'll conduct are things like what happens when you try to grow plants in space? Which way do the roots grow with less gravity? Another one that they've tested out is what happens when you try to spark a match in space? Does the flame act the same? Does that act differently with less gravity as well? And one of my favorites is where they had 2 identical twins. One twin lived on Earth for about a year. The other one lived on the International Space Station for a year. After that year, they compared it and contrasted the 2 twins. Turns out when you live in space for a long period of time, you tend to age a little bit slower. But not only that, you also lose a lot of muscle because you don't have as much gravity up here on the ISS. And the International Space Station looks really big here in our planetarium, folks, but it's not that big in actuality. It's only about the size of an American football field. If you've never been to an American football game, don't worry. You can also use the entire museum that we're sitting in. That's roughly how large it is. And what's really incredible is that this spacecraft is traveling incredibly fast. It's traveling at a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, and it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And also, this looks really far away from our planet as well, but the ISS is only about 250 miles above the surface of our world. 250 miles, that's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend, so not too bad. But to tell you the truth, folks, this is as far as we put humans into space nowadays because traveling into space is quite costly. Got to build yourself a rocket ship, buy yourself one, or pay for a ride. And once you do that, you have to account for all the rocket fuel. You need so much rocket fuel, you got to be able to escape the Earth's gravity. And once you acquire all that, you have to account for all the food, water, all the air you're going to be breathing while you're up here in space. So it gets quite costly quite rapidly. But for now, we're going to see the International Space Station slowly disappear to the city lights down below. And before we lose track of it, I want to add a nice little orbital path so we can see it as it slowly disappears. All right, folks, we've now zoomed so far out, we're now able to see our entire planet Earth from this vantage point. And I want to let you know that the space program that we're using here in the planetarium is something that you can go home and download if you want to fly through space, just like how I'm doing. The space program that we're using here is called OpenSpace. So if you go to www.openspaceproject.com, you can come across the link, you can download this, and it's so much fun. But just to let you know, OpenSpace is in its beta phase. That means it's not entirely finished. They're still working on it. And it's also open source, which means if you're a computer programmer, you can add to the software. Anybody can add to it. So if you love building space models, it's a fun thing to do. And also, folks, OpenSpace uses a whole lot of processing power. So if you have an older computer, you may not want to download it, may overwork that computer. But if you got something new, a gaming computer, give it a try. It's a whole lot of fun. It looks like we just have a little bit of data missing over the ocean, so we'll just ignore that. Don't look at that. But now that we got a sense of what we're using in here, let's make our way over to our nearest natural neighbor to us in space, the moon. And folks, we humans have been to the moon before. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. And that was the only brief presence of humans on another body in our solar system. But don't worry, folks. We humans are making a return trip back to the moon in the next few years, thanks to NASA's new space mission in the works called Artemis. Pretty much with this new space mission, NASA wants to send humans to Mars. But before we send humans to Mars, we need to figure out exactly how we're going to be able to live out here in space. So the moon is the perfect stepping stone to figuring out the logistics of doing that. And what's really incredible is that they're going to be sending the first woman to the moon. But not only that, they're also going to be sending the first person of color to the moon. But not only that, they're also going to be setting up lunar bases throughout our moon. Pretty much our technology has greatly improved in the last 50 years, so we're able to conduct much more science in much more compactable size. And one place that we definitely want to set up a lunar base is the South Pole of the moon. The reason why is because we found ice there, and that's going to be very helpful because we can melt that ice, pass electricity through it. We could separate the hydrogen and the oxygen, and both that stuff's really valuable when you're far away from home. So look out for any news about Artemis in the coming years. We humans should be heading back relatively soon. And folks, when you look up at the moon here on planet Earth, sometimes it feels incredibly close. It feels like you can reach out your arms and touch it, but it's incredibly far away. It's about 240,000 miles away from our planet. 240,000 miles, some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for 4 months nonstop going about 80 miles per hour. Although I wouldn't recommend it, the roads out here are poorly maintained. Hee hee hee. And from here on now, folks, we're going to need to use a more useful measuring stick because at this scale, using miles, it's kind of like using inches to describe the distances between cities because space is so big. So astronomers use a more convenient measurement known as light speed. And light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so since, well, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind. So everybody say bye-bye, moon. So cute. And now, folks, we're going to see the moon start to slowly fade away, just like how we saw with the International Space Station. And just like before, I want to add a nice little trail so we can keep track of all this stuff because, again, space is really, really big. And on our journey today, folks, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to the help of computer models like OpenSpace showing us the most accurate images and information available to us. And now the nearest star to us, the sun, is in view. So here comes the sun. Do, 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 do. And the sun's also incredibly far away from our planet Earth. It's about 93 million miles. Whew, 93 million miles, that's a good distance away. But in order for sunlight to travel that distance between the sun and the Earth, it only takes sunlight about 8.5 minutes at the speed of light. 8.5 minutes, that's not too bad. And this is a great concept because let's say the sun was to turn off all of a sudden, that last bit of sunlight would travel that 93 million miles, and then all of a sudden the daytime on Earth would become nighttime. And again, this is a great concept to keep in mind because let's say we're looking at a star that's 70 light years away from us. We're looking at that star as it looked like 70 years ago because the light that just reached us took 70 years to get to us. So when you're looking at really far away objects in space, it's like looking back in time in a sense, which is really neat. But now that we have a nice bird's eye view of our solar system, let's do a quick refresher of what we have. Right in the middle of our solar system, we have our star, the sun, the biggest thing by far. Closest planet to the sun, we have Mercury. Then we have Venus, Earth, that's us. And then the famous red planet, Mars, just on the bottom of our screen. And then past Mars, it kind of looks empty, but this is where you're going to find the main asteroid belts. This is where you're going to find roughly about 1 million asteroids in this region, give or take. And then past the asteroid belt, we have the really big planets, the gas giants, the Jovians. We have Jupiter, the largest of them all. Saturn, famous for its rings. Then we have our icy gas giants. We got Uranus, the funny one, and Neptune. And of course, we can add everyone's favorite and lovable dwarf planet, Pluto. So here comes Pluto on screen, just on the bottom left of our screen. And a lot of people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper Belt. And you're probably wondering, what's the Kuiper Belt? I've never heard of that before. Well, folks, this is the Kuiper Belt. So the Kuiper Belt is like a second asteroid belt past the orbit of Neptune. And what's really fascinating is that what you're mostly going to find out here are icy asteroids and short period comets that don't go too far away from the sun. And what's also incredible is that in 2006, our telescopes and technology greatly improved. So we're able to see much smaller objects much further away. And we came across more than 400 objects out here in the Kuiper Belt region at that time. And some of this stuff was bigger than Pluto. So we couldn't call all these things planets. There was just way too many of them. So all the astronomers on planet Earth had a great big meeting. They had to figure out exactly what you need to be considered a planet. They came up with 3 different criteria that day. And folks, that was the day in 2006 that Pluto went from being a planet to a dwarf planet. And I know a lot of people still have hard feelings about that. Trust me, I do a little bit. But that's the really cool thing about science, because as our technology improves, we're able to make better observations. So that's the one thing I love about science, constantly updating and changing. But I'm going to put away the Kuiper Belt because that's just a whole lot to look at. And now on screen, I'm going to be adding the many spacecrafts we sent out in the 1970s to explore our solar system. So now we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, all on screen. And of course, we also have New Horizons, the latest of them all, which did a quick flyby of Pluto in 2015. You can see that interaction right by Pluto's orbit. And all of these spacecrafts are all traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventures, Voyager 1, has not traveled as far as light travels in a single day. In order for sunlight to travel all the way out to the orbit of Pluto, it takes sunlight about 5 hours at the speed of light. 5 hours. Not too bad. But now, folks, it's time for us to leave our planetary scale behind us, because now we're heading out into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us roughly about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. All right, Alpha Centauri is going to be the star on the right-hand side that's kind of moving towards us. So we're right in the middle. Alpha Centauri is right over here. 4 years at the speed of light just to reach the next star system to us, folks. But again, that doesn't put into perspective how long it would take us humans to travel that distance. Well, if you're getting a rocket ship today, made your way over to Alpha Centauri, it's going to take you roughly about 8,500 years to make that journey. Whew, and that's just a one-way trip. But let's stop consider whether humanity has made its presence known beyond our solar system, because now, folks, we're stepping inside something called the radiosphere. And again, we're now inside something called the radiosphere. And this represents the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it begins in the early 1930s with strong radio waves, early television, radar signal, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. Since all these signals are electromagnetic, they are traveling at the speed of light. So this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is constantly expanding at the rate of 1 light year per year. So is anybody out there listening? And now, folks, I'm going to be adding these many markers onto the screen. These markers indicate the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found more than 5,000 confirmed exoplanets in the nearby vicinity to us, 5,000 other worlds besides our own. And that number is going to be increasing as the years continue because we have spacecrafts where the whole purpose is to find as many exoplanets as possible. In fact, if you look at the very top of our screen, you can see a whole heap of exoplanets in that one portion of the night sky. That's because we pointed a telescope in that direction for about 10 years. So you can imagine that 5,000 number will be increasing as we scan more and more of the sky. Now, to say if any of them are Earth-like with conditions suitable for life as we know it, well, we cannot answer that question quite yet. Pretty much new space telescopes are being developed right now, so those are on the drawing boards. They got to get built, and then they got to be launched into space. So we've got a little while before we can answer that question. But the more important point here is that quite a few of these planetary systems are within that 90 light-year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, well, the communication delays between hellos could be decades in time. And of course, planetary systems beyond the radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. But for now, folks, I'm going to be putting away our exoplanet markers, but I'm going to leave our radiosphere up on screen, because as huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way galaxy. And folks, we are now looking down on our Milky Way galaxy, and I have to ask, can anybody see their house from here? Just kidding. And folks, our Milky Way galaxy is incredibly large. If you wanted to cross it from one side to the other, it's going to take you roughly about 130,000 years at the speed of light. It is enormous. And our Milky Way is so huge, we estimate that there's at least 300 billion stars in our galaxy. If our recent discovery of so many exoplanets just within our small neighborhood and this massive star city is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we lose the Milky Way or leave it behind, I want to show you what it looks like from the side. You're going to notice that we live in a big flat spiral disk of the Milky Way galaxy. Kind of looks like a big pancake or frisbee in space. And this is important because when scientists and astronomers want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south. Instead of looking through the plane of the Milky Way, which is planets, stars, gas, debris, things that block their view of the universe. So keep that in mind. We like to point our telescopes galactically north and south. That's going to come important in just a little bit. But folks, the Milky Way galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. Now, we live in a local galaxy group which contains about 30 galaxies large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as we continue expanding, folks, you're now going to realize that galaxies are not evenly distributed in a nice little neat line where there's one galaxy here in a nice neat line and another one there. Instead, galaxies like to clump together in large groups and clusters, or they avoid each other where they create voids or very few galaxies. So you can kind of see some nice galaxy clustering towards the center of our screen. We can see very few or no galaxies on the very top left of our dome. And folks, this picture that we're now looking at represents the closest 30,000 galaxies to us in a space over 300 million light years across. We got to give thanks to an amazing researcher by the name of Dr. Brent Tolley, who compiled this amazing representation over decades of time with the help of dozens of astronomers. So big shout out to Dr. Brent Tolley. But now, folks, we have automated systems that are mapping even the most distant galaxies. So now we're about to see the very large scale structure of the universe. And remember, every single point of light that's not a star, that's an individual galaxy. And as we start to swing around the large-scale structure of the universe, I want to let you know that it's not in the shape of a bow tie or a butterfly as we swing around. Remember when I mentioned that we live in a big flat spiral disk of our Milky Way galaxy? Well, if we were to line up our Milky Way, it would line up just down the middle vertically like so. And again, we like to point our telescopes galactically north and galactically south instead of looking through the plane of the Milky Way. But astronomers still want to make sure that there was galaxies through our Milky Way plane, so we have this purple survey of galaxies. You'll notice we are still able to find them, just not as many and not as far. Pretty much we have to wait for our technology to improve, and then eventually we'll be able to map out all these areas that haven't been filled in yet. So it's just a matter of time. But let's continue pressing on, folks, because now we're going to be encountering these really distant, far-away objects known as the quasars. And the quasars are going to be represented by orange dots on either side of the large-scale structure of the universe. Also, quasars are short for quasi-stellar radio sources. These blazing objects are all billions of light years away, so now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. And here we are, folks, at the very edge of the observable universe. What we're looking at is something called the Cosmic Microwave Background Image, or the CMB image for short. And all evidence indicates that the universe that we live in is about 13.8 billion years old. This is data compiled by Planck and other radio telescopes. And this is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And this isn't your typical photo either. Instead, this is a temperature density image, where the light echoes of the Big Bang are color-coded, with the lighter areas corresponding to the hottest, least dense regions, and the darker areas, the coolest, densest regions. These fluctuations in temperature and density are extremely tiny. They vary no more than 1 part per 100,000. But these tiny differences eventually gave rise to a large-scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, folks, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But now, folks, we've traveled as far back as the law of physics can physically allow us to go, so we only have one direction left to go, back home towards planet Earth. So let's find a nice entry point to all these quasars and galaxies. Ooh, this looks like a good spot. And let us make our return trip back to planet Earth, everybody. All right, everybody, we're crossing an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. We live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. And with that thought, I'll remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to peer into their telescopes and see into the great beyond, allowing you to partake in the wonders that the universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we made our way back into our Milky Way galaxy. We're heading straight through that radiosphere, and we're making our way back to our star system, our solar system, our little neighborhood in the vastness of space. And now we're about to pass those spacecrafts we sent out in the 1970s to explore our solar system, passing the orbit of Pluto and the Kuiper Belt region. And now we're making our way to the third rock from the sun, our homeworld, planet Earth. All the people that we know, love, or ever learned about in history all lived on this one planet. And now, folks, we're about to pass the orbit of the moon, the furthest we've ever sent humans out into outer space. And as we make our final approach back to planet Earth, this is going to be the end of our Tour of the Universe show. And I want to thank you so much for stopping by and watching it with us today. I hope you did enjoy it. And if you want to share this exact show with a friend or family who are unable to visit, you can watch this exact show on the Morrison Planetarium's Facebook page or the California Academy of Sciences YouTube page. But hey, look at that. We made it back home safe and sound just in time for dinner time. And that's all that time we have for today, folks. Make sure to get home safe, and we'll see you next time.